Let's discuss the factors affecting the loudness of the sound instruments. So, the first factor that affects the loudness of the sound is the distance from the sound instrument. Okay, so by this I mean to say that suppose if you have a drum like this, and if you hit this drum, then this drum is an example of percussion instrument. It has got membrane, and then the sound will be produced, right? So that means you will see the compressions, rarefactions, again compressions, rarefactions, again compressions, rarefactions, and finally they are going to reach your ears, right? So if this listener is very close to this sound producing drum, then the loudness of the sound would be comparatively larger, right? But if this listener is shifted somewhere over here like this, that means the distance earlier, let's say the distance was d1, now the distance has increased d2, and with the increase in the distance the loudness keeps on decreasing, correct? Okay, so we can say that loudness is proportional to 1 upon distance. Farther you go away from the source of the sound, the loudness keeps on decreasing. And why is that? Let's try to understand that. Now suppose this is the drum that produces the sound, this is the membrane like this, and now these are the air particles. Now we know that the sound produced will be absorbed by this sound particle, then this sound particle will go in this direction, and here there is another sound particle, it is going to collide, and then it is going to give the energy to this sound particle, and again this sound particle is going to come back. So this is particle number 1, let's say particle number 2, then some distance apart there is particle number 3. So this particle number 1 is going to absorb the sound first, then it is going to move in this direction, it is going to transfer, it is going to collide, it is going to transfer energy, and again this 1 is going to come back. Now this 2 receives the energy, 2 goes in this direction, collides with the third, transfers the energy, and again comes back. But what happens is during each collision some amount of energy is lost. So suppose here the sound energy is 100 joule, maybe over here it may be 99 joule, because due to the collision some amount of energy will be lost in form of heat. So that means as the sound keeps on going in the forward direction, the loudness keeps on decreasing, correct? This is the reason. Now the second thing is the surface area. If you have two drums are percussion instruments. Percussion instrument means having membrane. Now this is drum 1 having smaller area, let's call this as drum A, and then you have another drum which has got more surface area, let's call this as drum B. If you hit this drum and this drum with same amount of force, the sound produced from here will be less louder, here it will be more louder. So here we can say that loudness is directly proportional to surface area. Now let's try to understand why. Suppose in two different stadiums, and both the stadiums are different but both are identical in all dimensions. In stadium number 1 we have 10 people, and in stadium number 2 we have 10,000 people. The people in both the stadiums are supposed to shout. So we know that if 10,000 people, if they start shouting, all of their sounds is going to get added up, and it is going to produce a very loud sound. In the same way, here the number of molecules or the number of atoms which are vibrating are less, but here the number of atoms which are vibrating are more due to more surface area. So if you hit this and this, more particles are set into vibrations, so all vibrations produce sound, and the sound will be added up to produce a louder sound. So more the surface area, more will be the loudness. Had it been inversely proportional, less is the distance, more will be the loudness, like this. So if when this listener comes towards the drum, the loudness of the sound will increase, and going far away the loudness will decrease. The third factor is the energy. energy with which the instrument is struck. Right? Okay, sorry, is struck. So you can also call this as actually a force. So here again we take both the drums. Now this time I'm going to take both the drums of same surface area. So these both the drums A and B are identical in nature. Now I am exerting a lot of force on drum B. So I am putting lot of energy in drum B, whereas I am just hitting drum A with small amount of force. What is going to happen is, if we place few pieces of papers over here, when I beat this drum, this paper goes up. When I beat this drum, this paper goes up. But if I am hitting this drum harder, then the paper is going to go up by a more distance and again fall back. So the maximum distance that this paper goes up is called the amplitude. So we can see more the amplitude, more will be the loudness over here. If you struck this drum with less force, the height of the paper going up will be comparatively less, so amplitude will be less loud sound. So more the force, more the energy you are putting into the drum, so the particles will oscillate with more amplitude. More amplitude means more the loudness. So harder force, say I am striking this with 100 Newton force, over here with 1000 Newton force, just an example I'm giving you. It may be possible that this force is strong enough to break the membrane, but just an example. So here the sound produced will be of larger loudness, and here the sound produced will be of smaller loudness. Correct?